Hello and welcome back to Triplicate, home of interesting electronics, and today we're going to move on with our Arduino based alarm clock project. So before we can actually get down and write any software, we need to know what the alarm clock's actually going to do. Well, this is a little alarm clock I've had for years and years and years, and it's absolutely brilliant. There's so many alarm clocks that seem to be so complicated and you need to read the manual just to wake up in the morning. Well, this one, you don't need the manual, you can see exactly how it all works just by looking at the front. Okay, firstly we have a switch here, which is run, time set or alarm set. Self-explanatory. I have an alarm on off switch. What can I say about that? When we're setting the time and the alarm, we have an hour and minute button to set them, and finally we have a snooze button which also turns the backlight on, and that's it. So I'm proposing to, as far as we can, use that as the basis for our alarm clock design. Now, specifications. Do we write specifications or do we just press on and write some software? Well, I was taught to write detailed specifications and then sort of implement them and tests of the specifications, and then that was your final software. However, spending many years writing user interfaces for synthesizers specifically, if you do that you find that it meets the specification but it's absolutely rubbish and you have to rewrite it anyway, and trying it out as you go till you get something that works nicely. So what in the end I do is I write a bullet point specification, implement it, and we see how we go and try it out and adjust it as we go along, which is what we're going to do here. So, without further ado, let's get on and look at the specification for our clock. Okay, so we're designing a clock, so most of the time it's going to display the clock, so the time. So the clock time is displayed in 24-hour format. We're not giving you a choice, and the middle decimal point will blink once a second. Okay, normal operation, that is everything except setting time. Run, it's labelled on our little travel clock. Okay, pressing buttons 2 and 3 together toggle the alarm on and off. So you get up Friday morning, you just press 2 and 3 together and it isn't going to wake you up early on Saturday morning. Similarly, you get to bed Sunday night, you press 2 and 3 together again and it'll wake you up nice and early on Sunday morning. Lucky you. Okay, when the alarm is sounding, pressing buttons 2 or 3, enter snooze mode, and when the alarm is sounding or in snooze mode, pressing and holding buttons 2 and 3 cancels the alarm. We've got up, we don't need it anymore. Okay. Yeah, and the alarm automatically turns off after an hour in case you get up and forget to turn it off. Okay, setting the time and alarm. Again, simple. Pressing and holding button 1 goes to alarm set mode. Our little alarm clock has a little 3-way slide switch. We've got 1 button, so this is not quite as good, but it's all we can do. Continuing to press and hold button 1 goes into time set mode. The display will display something useful, I guess. And when in either of these modes, button 2 increments the hours and button 3 increments the minutes. Pressing button 1 once we're in our set mode clears that set mode, and any period of inactivity in a set mode will automatically clear the set mode. And when I say clear the set mode, it goes back to normal mode. Okay, LEDs and buzzer. Well, we've got 4 LEDs, but I'm only proposing to actually use 3 of them. LED 1 indicates the current alarm mode, off for off, on for on, and flashing for sounding, and flashing differently for snooze. Easy. Okay, LED 3 indicates alarm set mode, probably flashing. LED 4 indicates time set mode, again probably flashing. And the buzzer is only used to indicate that the alarm is sounding to wake you up. Okay, so now we have a specification. Let's get going and start some coding. Okay, so I've been beavering away and written some code, and I'll show you what I've got. Now, I sort of talked about clock set mode and alarm set mode, and that is actually the way I go about writing anything with a user interface. I have a mode. This is the current mode the software is in. And then I have a series of actions which can or cannot affect that mode. So, for instance, if we look here, I've got mode clock, and that is just the normal mode displaying the time. And the actions we can have here are, for instance, well, the clock can generate actions. You see here I've called clock update every tick, and the actions the clock can return are action clock 1 second, at which point the display is updated and the decimal point is turned on, and action clock half second, at which point the decimal point is turned off. The clock will also have actions of alarm start and alarm stop, or alarm on or an alarm off. But I haven't got onto those yet. And as you can see, we've only got one mode. We're just trying to get the clock running for now. So if we start to look into this, clock update is called every tick and is in clock INO. Okay, and that just calls clock add and adds tick time millis, in our case 5 milliseconds, to the clock value. I've defined a structure called time, which has milliseconds, seconds, minutes and hours in, and also contains a display string to display the time on the display. And I've written a clock add function which you can add a number of hours, minutes, seconds and milliseconds to the clock, and it just goes through each part of the clock, the milliseconds, the seconds, the minutes and then the hours, adding the required amount on and carrying as necessary. Okay, so as I said, every time the clock ticks over a second, display time is called, and every second and half second display DP for decimal point is called. And the display time just prints the hours and minutes to the display string and displays the string. The display DP function isn't actually written yet. We'll see if we can write that in a minute, shall we? Okay, so should we see if that works? And there we go, 11:05, which is just a time I put in to start. Right, now the problem with working on a clock is it happens slowly. In fact, to test everything you've got to sit there for a whole day. So, to try and speed things up and make them happen a little quicker so we can actually debug the thing on a sensible time scale, I have, and I've lost it. Here we are, clock update. If I insert this one and comment out that one. Okay, now the clock is running at 50 times normal, so we can actually see the minutes counting up at approximately what seconds would count up normally. So, shall we try that? Oh yes, and it's actually counted up to 11:06, so I've been a minute looking for that line of code. Let's go. Okay, now you can see the minutes counting up pretty quickly. Okay, so I'm now going to shut you off and get this decimal point flashing at a 1 second rate and bring you back. Okay, so our decimal point function. Here we have this. I realise there's a typo there. Display DP. Right, display DP. I've just created an array of 4 decimal point values, which are either on or off. So that function just puts the value in the digit and is done. And when we set the segment value, if the decimal point value for that segment is set, we simply clear that bit in the 7 segment register, 7 segment value, and it's ANDed with not the value because of course the logic of the segments is inverted. So shall we try it? There we go, and of course the decimal point will be flashing ridiculously fast because I've got the clock running fast. So I'll turn the clock back down to running at normal speed, and we should have a nicely blinking LED. Right, I've clicked the wrong button. Silly me. No. Right, it looks like my clock actions are not happening as I hoped they would, and I think what I'm going to do is I'm going to turn you off and sort the problem out and just tell you what I did wrong. Okay, so after a few minutes fiddling around, I discover the obvious bug, the obvious mistake, as a result of using copy and paste to generate new code. As you can see, it sends a clock second action when the seconds are 0, and it sends a clock half section action when the half seconds are 0. No, when the seconds are 0 the same. So that is my mistake. That should be 30. And while I'm here, I notice I've made another mistake in that this clock update will be called 200, 1000 over 5, 200 times a second. So it'll actually send 200 second actions and 200 half second actions. So we need to only do that if clock time, what am I typing? Time. Yep, dot milli equals 0. So that should send one of those actions each per minute. Shall we see if it works now? And oh yes, I'm good. We're going to have to sit and wait for a minute for it to display. Oh, there we go. But it's still not flashing the second. No, hang on. The action is a second. Okay, so if clock time dot milli equals 0, okay, so to see what's going on, I decided to use the LEDs as a test output. Again, with embedded stuff, you've got to use whatever's to hand to try and get some information out of your program to see what it's doing. So I simply set up a LEDs test which uses the LEDs to give the first lowest 4 bits of test val. So going back into clock, so every time the milliseconds is 0, then we've added a counter variable. So if seconds 0, it increments the counter and shows it in the LEDs, and if seconds are 30, it increments the counter and shows it in the LEDs, at which point we discover embarrassingly silly blunder. Of course, if seconds are 0 and seconds are 30, then the decimal point is going to flash once a minute, not once a second. So we want it to flash on when millis are 0, so we are going to remove that. We're going to pull that variable definition out of there. Clock millis equals 0. We're going to leave this LED stuff in and have that. If clock millis equals 500, oh, what am I doing? Clock millis equals 500, we're going to do that, and we're going to see if that does anything. Okay, well, if you look at the LEDs, they're showing that as being right. You can see one pair is coming on the second and one pair is changing on the half second, but still no decimal point. Ah, that is why, because if we don't display clock time, it won't pick up what I've set the decimal point to, so I need to re-display the time there. And this one should hopefully work. That's it, it works. Finally, about an hour and a half to get a decimal point to blink on and off once a second. Okay, so I'm going to turn you off there, I think, and take stock and see where we are and see how long this video is. Okay. Well, this seems to have turned into a bit of a long video, and the second half certainly we didn't seem to get an awful lot done. Just got one decimal point working. The aim of these videos was never just to say I did this and then I did that and am I clever. It was to sort of bring you along on a bit of a journey, and sometimes that journey can be a little bit longer than we would have liked, so welcome to my world. And on that note, I think I'll sign off now from Triplicate, home of interesting and sometimes slightly frustrating electronics, and I'll see you all next time for further work on the Arduino alarm clock. Goodbye. Come on, wakey wakey. I think what you need is a nice long walk. Oh dear me, that's a tough old life.